Hey everyone, this is Dr. Keith again. So you may remember in the last chapter we talked about why relational databases are important and demonstrated here a set of data that was initially what we call non-normalized data, meaning that we had lots of redundancy and same product description repeated, same name repeated. Then we went through this process of separating the data out into multiple tables. Of course, we're representing all the tables here in the same spreadsheet. In reality, these would each be a different database table. The analogy in a worksheet here is that normally each of these would be their own sheet. So remember, in a database is like a spreadsheet in that database tables are similar to worksheets, separate worksheets in a spreadsheet or in a workbook. Maybe this is probably a better word here to put workbook. So a table is more like a worksheet within a workbook. A record in a database is like a row in a spreadsheet or a worksheet. And then a field in a database is like a column in a worksheet. So what we want to do is teach you what's called the entity relationship diagramming notation to represent all of these tables diagrammatically or visually. So the idea is that if we create a diagram, a visualization that represents exactly how the relational database should be structured, we can pass that on to a database developer to actually build out the database. So entity relationship diagrams, or ERD as we call them for short, it's kind of like a shared language that both the technology side or the tech side and the business side should both understand. When I've done consulting projects, they always go best when the business side would give me a set of diagrams, which often would include an ERD that shows me exactly what it is they're looking to have created. That reduces misunderstandings and mistranslations of business requirements. So we're going to use a fairly common or standard notation. We need a diagramming tool to create this in. Excel is nice. It lets us see exactly how the data would fit, but a diagramming tool is needed. So in the past, we've often used something called Microsoft Visio, which is still a very common tool, but lots of good and free online tools have become available. One of them is Lucidchart. This isn't the only option, but it's a fairly standard one these days, or a common one, and it allows us to create flowcharts, which we'll learn later in the semester, but also ERDs. So pause this video if you need to. Sign up. There's actually an educational account that you can sign up for. If we go to pricing, here's the student one. You can sign up, use it for free. Or if you're an instructor teaching this class, obviously you can use that. So I've already created an account. I'm going to go ahead and log in. Okay, here I have a bunch of flowcharts I've made in the past. I'm going to make a new ERD. So I'm going to say new document. Wait for a second for this to load up. Alright, and I have a bunch of shapes here. Well, these are flowcharting shapes or other common shapes. I want a different set of shapes. So I'm going to click down here on more shapes. Open up this tool. It says here's what you've got so far. I don't currently need these flowchart shapes, so I'm going to take those off. I'll leave my default ones, why not? But what I want here is entity relationship. So check that box, save, and here we go. Entity relationship. I'm going to move these up after the standard ones. Okay, these are our shapes. So let's start with, I like this one right here. So I'm going to pull and click and drag this out, and it gives me a few options. I'm going to click on entity here and change this. What I want to do is create our same orders database that we started with. There we go, right here. So in this database we have 3 tables. Alright, in entity relationship diagramming, I'm going to call this ERD. We also use, and it's just one of those things you have to learn, we also use different names to represent these same things. Okay, so in an ERD, a table is called an entity. Alright, so this thing right here, whoops, this is an entity, and it's going to represent one of our tables. Here we have different fields, and then whether or not it's a key. So here on this entity, I'm going to change that name to, let's start with customer. Typically, we'll name these using a singular, as a singular noun, customer, not customers. All right, so it says fields. We can adjust these things later. Show header. Awesome, sounds good. So I'm going to come over here, and now let's add each of these fields. Now, technically, in an ERD, we don't call this a field. They've used the word field here because it makes sense and it's natural to database developers. But this is actually what's called a property. So each of the fields here are properties in an ERD. So back here to our table down here. Oops. A property in an ERD is like a field in a database, which is like a column in a workbook. And as we'll talk about in a moment here, a record is called an instance in an ERD, and a row in a workbook. All right, so back to our drawing here. So this first field, typically we'll put our primary keys first. In the customer table, our primary key is the one that uniquely identifies every record in the table, which is, of course, account number. So let's make account number here. Key, yes. Let's double click on this. I'm going to call this a PK. Next field. This is not going to be a key. This is simply going to be their first name. Next field is also not going to be a key. This is their last name, and so forth. I can sit here and I can add more fields, and I can just keep going. Obviously, there's more stuff we're going to want to keep track of. Email address. Let's just add one more. There's a bazillion things you'd want to keep track of about a customer, but we won't list all of them here. So, do you want to share this with other people? Not now. Thank you. All right. Turn that off. This whole thing, once again, is our entity. Each of these are called properties, which we call fields in databases, and we have many instances of a entity that will be stored here in this entity. So an instance would mean a specific customer, Homer Simpson, Marge Simpson, all those things. We don't actually show any real data here in an ERD. The ERD is only meant to represent the entities, the properties, the keys, and the relationships between entities, which we'll get to in a bit. So it's not like in Excel where you'll actually see the real data. So I like starting here because it's a lot easier for people to think about how the specific data that gets stored, and I wanted to show that to you here. But now we're going to abstract away from the actual data. So customer, the next entity we're going to make is orders. So let's grab another entity relationship or entity here. Let's call this order. We're going to have some type of primary key to uniquely identify each order. So I'll have one called order number, and this will be the PK. We're going to have some type of order date, won't be a key. Some type of total, which also won't be a key, order total. We'll probably have other things like, let's see here, payment type. What else did you store about an order? Okay, we see account number here. Remember what account number is for? It was so that we could say, show me total amount that Homer Simpson has spent, and I could look up Homer's primary key value here, account number 1, and then I could come over to orders and identify all of the orders placed by Homer. So again, over here it's called a primary key, but when it's in the orders table, it becomes a foreign key. So let's go ahead and add that foreign key. And here, instead of keeping it blank, I'm going to type in FK so that we know that this is meant to be the foreign key, account number. So you might ask, do I have to name this field the same thing that it's named in the table that it's related to? No, you don't. You could call this anything you want. Call it Purple Monkey Dishwater, and as long as the numbers over here actually represent and match up to their appropriate numbers over here, then you can still call this a primary key, foreign key relationship. Okay, so we have two entities. We're not done, but let's go ahead and draw the relationship between these entities. To do that, click here on this arrow tool. I don't care if you want to have a curved or right angle line, whatever you feel like. And what's important, though, is we want to draw the relationship beginning on a specific field. See how that red dot changes? If I draw starting from here, it's going to create the relationship from fname, but I don't want to do that. I want to indicate that the primary key account number here is related to the foreign key account number over here. In particular, there's a cardinality involved in this relationship. So you may remember this from the last video. If you don't, you may also want to take a look at it in the reading here. So scroll down, you'll notice that cardinality is talked about right about here, relationships. So there's three types of cardinalities. There's one-to-one, meaning a record or an instance of one entity is related to one and only one instance of another entity. One-to-many, which might be the most common, and then also many-to-many is also pretty common. So let's think about what the relationship is from customer to order. A customer can place how many orders? One and only one, or many? Clearly a customer can place many orders. So it's at least a one-to-many relationship from customer to order. An order can be placed by how many different customers? Well, clearly an order, and actually this is a decision you can make. It's a business decision. To make things simple, it's usually pretty common to have an order be placed by only one customer, especially for small items, small ticket items. So this is an example of a one-to-many relationship. So the way we draw this relationship, we always start, and this is something specific to the Lucidchart tool. This is different depending on the tools you use, but in this case, I'm going to start on the one side and click and drag to the many side. So I start here on account number, and I click and drag, and notice it adds this little line here and these crow's feet over here. What does this mean? These little crow's feet means many, meaning, and you always read it from whichever side you start, you include the relationship or the cardinality on the opposite side of that, meaning a customer can have, I ignore this, many orders. If I start on the order side, I skip this one and go to this little symbol right here. An order can be placed by, I skip the crow's feet, this little tick mark means one. So an order can be placed by one and only one customer. So tick mark means one, crow's feet means many. Pretty straightforward. Let's go ahead and add our next line item, or excuse me, add our next entity. Let's grab another shape. Let's put this in here. Let's make this the products entity, or product. So let's stick with our sporting goods example. Let's assume that we sell sporting goods. Let's have some type of product. Usually it's like a product ID. I guess we can stick with our number notation. That's not a problem. We'll call this the primary key. Let's not spend a whole lot of time on this. Let's give the product a name, and let's give it a price, sales price. Okay. So you may remember this from the last video, but I want you to think about what the cardinality is from order to product. So we're going to have to draw make this relationship and put the crow's feet and the tick symbol in the right places. In other words, an order can include one or many products on it. Well, think for a moment, what does this product represent? The example we used were these conceptual products like football, baseball, basketball. In this case, products should also have another field, maybe called quantity on hand. Meaning, how many of these do we currently have in our store? All right, let me add these lines back in. Add one of these, bottom border, there we go. So maybe we have 100 footballs, 200 baseballs, and 50 basketballs or something like that. So this row represents a conceptual football, not a specific football. It just says we have footballs and we have 100 of them. Now this will be significant because in the next example I give you, we're going to do it a bit differently. So understanding that each instance over here represents a conceptual product, then a single order can have many products on it, right? Because on order number 1, I can have, notice from our last example, order 1 includes 2 different products, both a football and a baseball. Okay, so clearly there's going to be crow's feet on this side over here. Now, a product, though, can appear on how many different orders? All right, let's go back to the data again. This football right here, can this appear on more than one order? Yes, it can, because here in our order line items, we see that product ID 1 appears on order 1, but it also appears down here on order 2. So a product can be on many orders. So in this case, the relationship from product to order, and I'm going to put it up here for now, and you'll see why, is going to be many to many. Now I need to adjust this side because this is a 1 on this one. So let's fix that. And the way we fix it is we come right here. These are our shape ends. So I can reverse them, or I can just change one on this side to another crow's feet. So these other symbols include something else we'll talk about in a little bit. But this represents now many to many. And I put it up here because we don't have a primary key, foreign key relationship yet between these two tables. We simply say there's a many-to-many relationship. Now in some cases, this is perfectly fine. If we do this, however, it implies that there's going to be what's called, some call it a linking table, or you might also call it an association class, or association table in between these two. So this is the issue we ran into in our previous video, where because we didn't have a one-to-many relationship between orders and products, we didn't have a simple way to move a primary key from one side and make it a foreign key on the other side. So we had to create this in-between table here called order line items, where we took the primary key from orders and we took the primary key from products, and then we have a repeated row in this association class for each one of the items on an order. So many products, and then this product appears on many orders. So we're going to have to do something similar over here in our ERD. Let's do that now. So what I'm going to do is delete this relationship, and instead, where do I want to put this? I guess I can just scroll over. Or let's move these over. All right. So in between here, I'm going to grab another entity, and let's call this one order line item. Order line item, it needs a primary key, but what we can do is we know that we're going to have to take the foreign key from order, or the primary key from order, and the primary key from product, and put them in this field. So let's do this first. I'm going to call these foreign keys. Order number, foreign key, product number. And then we know we're also going to keep track of the quantity of that product purchased. So order line item, think of this as an example of if you were to take all of the receipts for the store, to have a list of all the items purchased, and maybe cut off the top and bottom of the receipt so it's just a flat list of all the items and quantities purchased. That's exactly what we have right here in this order line items table across every order in the store, a report of the order it appeared on, the product purchased, and the number of that product purchased. So that's what we've got right here. And we're going to have two now, instead of a many-to-many relationship, we're going to have two one-to-many relationships. We're taking the primary key order, and we're putting it over here. And we're taking the primary key product and putting it right there. So now an order can appear many times in an order line item table, but a particular order line item is only related to one and only one order. You want to see how it works? Take a look at it right here. Here's a single line item. Okay, an order 1, can have many rows in this table, and clearly it does. Here's 2 rows associated with order 1. But an individual line or an individual row is only ever going to be related to one order number. So this row only belongs to order 1. This row only belongs to order 1. This row only belongs to order 2, and so forth. Whereas this row here, or this instance, is related to many rows over in this table. Row 2 here is related to many rows over in this table. Hence the one-to-many relationship. A single instance here is only ever related to one instance here, whereas the reverse is the opposite. A single instance here is related to many instances over here. Hence the one-to-many relationship. So same thing from products into this table. A single product here appears many times over in this table. Here's 2 of them. This product appears many times over in this table. 1, whoops, 1, 2, 3. So each of these has a one-to-many relationship from here into here. So there are not often rules that you can memorize and follow in IS-Field, but this is one of them. Actually, I can give you two rules right now. First of all, whenever there is a one-to-many relationship, you always take the primary key out of the one side and make it a foreign key in the many side. So see that holds true in every place here. In this one-to-many relationship, the primary key order number becomes a foreign key in order line item. Primary key product number becomes a foreign key in order line item. So that's rule number one. Rule number two is anytime you have a many-to-many relationship, like we did between order and product, every single time you are going to have to create an association class or linking table or whatever you want to call it in between those two tables, and you will delete that many-to-many relationship and turn it into two one-to-many relationships coming from what was previously the many-to-many relationship into the new linking table or association class. So those are two practices or rules you'll always follow. Alright, we're not quite done. Order line item. It needs a primary key. Is there something we can use as a primary key already? Well, and we would call that once again a semantic key, meaning it has meaning outside of being a primary key. Let's take a look here. We can't use order ID because it appears multiple times. Can't use product ID because it appears multiple times. Over here, therefore, I created this artificial key called line ID, and I simply gave it consecutive numbers. We don't actually have to do that. What we can do instead is make what's called a composite key. So let me explain what that is. A simple key, the opposite of a composite key, is what we have here, here, and here. These are simple keys because it's comprised of only one field. It only takes product ID to uniquely identify every row. It only takes order ID to uniquely identify every row. We can create a composite key by adding two fields together to uniquely identify every row. In this case, will the combination of order number and product ID ever be repeated across multiple rows in this table? Will you ever see a combination of 1 and 1 multiple times in this table? The answer is no, because if order 1 placed by Homer included product ID 1, a football, more than one time, rather than adding another row for it, we would simply increment the quantity to 2. And there would still only ever be one row for the combination of 1 and 1. Same thing with everything else. Will order 2 placed by Marge ever include product ID 3, the basketball, more than once? In this case, she bought 1 basketball on order 2. If she were to ever to buy 2 basketballs on order 2 and repeat this combination, we would simply come here and add to the quantity. So the combination of order number and product ID will be a composite key, and it's a valid primary key in that case because it will always be unique. So what we do is we simply change this to pk/fk, pk/fk, meaning each of these are a foreign key that matches up to another table, but the combination of the two of them is a composite primary key. Alright, back here in this table, let's indicate this by coming right here and saying pk/fk. Come on. Work. It's giving me problems. Why don't you want to let me edit that? I know what I need to do. Let me try and click here on this one, then hit tab. There we go. pk/fk. Okay. So, composite primary key, simple primary key. Alright. Artificial keys, order number, account number, product number, they're not used anywhere outside of being a primary key, so these are artificial keys. Again, a semantic key would be something like customer email address, if that uniquely identified everyone. Or, I'm not sure if there's anything we could use here. We kind of have to use order number. I guess if every product name were unique, you could use that as a primary key, but typically we don't like to have text in our primary keys. Anyway, this is our order line items example. walk through it again, see if you can create it without watching this video for practice, and then move on to the next example.